I have completed my BSc Engineering and Honors at U for my electrical engineering. We'll also be seeing Paul Mafune, who is a senior software engineer with a BSc and BSc Honors in pure and applied mathematics, as well as specializing in cosmology for her honors, both of which a few regarding presentation throughout the series. Please feel free to add the questions into the chat. At the end of this presentation, we will be looking at the questions and addressing those. I'd also request everyone to turn their cameras off so that we can save on bandwidth. And I'd also just like to point out that we will be recording this presentation. So let's go ahead and look at what we'll be covering in this presentation. First of all, we're going to look at churn and churn modeling. What is churn modeling? Why do we need to know this? What is the essence of it? And then we'll look at churn modeling workflow to understand how to incorporate it into our business, and then head over to a demonstration to create a model, and then come back and Paul will look at a few behavioral models that Optimum Solutions have deployed, and then go over to a few next steps that we can take on from there. So let's go straight ahead and look at what customer churn is. Well, in simple terms, it's the rate of loss of consumers or customers. As you can see with this general equation, over a set period of time, how many consumers or customers have we lost? And why is it calculated? Well, we could be losing customers due to dissatisfaction, competition, a change in life cycle, for example, a project that's come to an end, a contract we haven't renewed. Maybe there's no retention strategy or even loyalty. Well, knowing these will help us understand our business and the health of our business. We know that we will lose customers over time, but if we know at which stages we lose them, we can mitigate these factors. For example, understanding the advantages and managing customer churn will help us retain these consumers and customers. The most important advantage being marketing costs being saved. We don't need to sway our customers anymore. We already have a relationship. We trust them, they trust us, which means we'll have repeated purchases from these consumers. There's these same profits coming in because of these purchases, and these same customers will give us with social advertising, for example, word of mouth, social media, which exposes us to multiple clients and a new set of customers. Loyal customers also give us valuable feedback. We can improve our products and services, and this will also allow them to pay premium prices because they trust us. So now the question is, how does AI or machine learning solve such a business problem? Well, first of all, let's look at the churn modeling workflow. What we're trying to do is predict which customers would churn, right? So first of all, we're going to have historical data that gives us insight into our customers' behavior. There's details about the consumer, the products that they're using from us, their demographics, if they've churned or not. Then what we need to do is predict these customers that would churn. What attributes, what about behaviors would tell me that they are going to churn? And then we'll look at a critical analysis of that reason. Are there trends between multiple consumers that show us that there's a trend for customers to churn? And most importantly, we need targeting marketing techniques to identify and contact these customers to provide catered solutions. So now you ask, great, where does AI or machine learning come into play? And that is right here, where we predict the customers and how they churn. Machine learning can make this process far easier. So if I'm a telecommunications company, for example, I want to know more about my base. Where are my customers from? What is the basic structure? Are my customers churning often? If they do, how often? Can I create a model to predict this churn? And most importantly, can I apply machine learning? So let's go over to a demonstration of creating such a model. As the distributors of MATLAB and Simulink products, we will be using MATLAB. So as I open MATLAB, I just want everyone to notice that I've opened a live script. On the left is the current folder, which I am, so all the files that I have access to. And I'd like everyone to keep their eye open on the right-hand side at the workspace to see all the variables that pop up that I'm going to be creating. This live script not only has text, images, and hyperlinks, but if I scroll a little down, you can see I also have code. So if you're interested in how to create such live scripts, I've included a few hyperlinks to follow. At the end of this presentation, you'll have access to a link, an evaluation form, a survey, and you'll be able to have access to both the live script and the details of the data to run this when you complete the survey. So now let's look at a workflow or a model that we can use to create churn models using MATLAB. Here it says, first of all, we're going to import data, prepare it, select a few variables and features to create, fit, and test a model, and then make a prediction. Most importantly, we need to notice that this is by no means a strict method to follow. It's just a well thought out flexible guideline that we can use to assist in our identifying a way to navigate in making such a model. So let's go over to the first point in our model, and that's importing data. Here what we've done is we need to know the data that we're going to be importing. What are we importing? Is it a CSV file? Well, here in the link methods for importing data, it tells you the correct functions and the importing wizard, which is an interactive way to import data if you're not sure of using functions. In our case, I've actually found a data set from Kaggle for a telecommunications company. The data has the customers that have churned, the services these customers are taking, and the customer information as well as their demographic. I've also used the read table function to pull in this data, and the summary function to look at a bit of what this data is about. Here, all of these columns are saying salary of character vectors, and that's not helping me, which is why I'm going to look at part of the data using the top k rows function, and I'm looking at the first 10 rows. Here you can see it's the data table itself. I can scroll over and see all the entries, and at the far end, I even have churn, if they've churned or not, if they've left or not. Another way is to open the data on the workspace, the actual variable itself, and look at the table itself. And if I scroll up, it's just to make sure that I've said read table is equal to data, which is why I can open data. Now scrolling down, let's look at pre-processing the data. Summary told me that it's a salary of character vectors. Well, if I'm doing analysis, I can't use such a variable. We can't necessarily create sums of these variables. So what I'm going to do is convert all of this into categorical variables. It helps me discretize the variables and create distinctions between the entries. I've also included a link to see the other advantages of using categorical arrays. I've chosen the columns that I wanted to convert and use the convert fast to change them all into categoricals. Now when I use the summary function, what it does is it not only calculates all the possible outputs in each column and sums them, but if I have columns which have double entries, it calculates the minimum, the median, the maximum, and even the number of missing data I have in that column. I know that customer ID are unique identifiers, so I'm just going to remove that because it's going to be noise. Remember, we're trying to find groups of data. We're trying to understand our data. So now let's look at a bit of basic exploration. I just want to see my customer base. I don't want to do a lot of analysis. I just want to understand. So first of all, we're trying to go ahead and look at customer churn. I've plotted all the customers that's remained against those that have left. And here you can see that 73% of my customers are remaining and 26 have left. Well, percentage-wise, that's okay. But if I look at the actual numbers, 5,000 against 2,000, that's a very tight number. So small differences in percentage could be quite significant. Remember, we're not trying to retain every single customer. Maybe initially we are, but over time, we're trying to find a base and understanding of the customers that are trying to churn. So let's go over a little bit more detail. What if I want to find some form of relationship between the tenure and the number of customers that's churned? I've plotted all the remaining customers at the top and those that have churned, and at the top I can see most of my customers are at the longer ranges, and those that leave this company are using short-term tenures. So there seems to be these bumps in my histogram, and it's just probably attributed to the fact that we have 6 to 12-month contracts available for these customers in my telecoms company. Let's look at another way in analyzing our data. What about scatter plots? I've plotted against how long the customers are in my company, and there's nothing. There's no glaring relationship. There's no obvious clusters. So I'm going to briefly move on and maybe count the differences by using a heat map. I'm going to see all the contracts. So I offer month-to-month, 1 year and 2 year contracts and see if customers are churning between these. And once again, month-to-month seems to be the contract that both churns the most and remains the most. That's not a lot of insight I can take into, which is why I'm using the group summary function to sum all the total charges with respect to the contract and then plot the difference between churned customers and remaining customers to see some form of a relationship. Here we can see most of my revenue is being lost in month-to-month customers for my churn customers, and most of my revenue that's coming into the company is from long-term customers. So once again, you don't need to use visual analytics. We can always use other forms, for example, statistical analytics. Here I'm using the cross-tabulation function to tabulate the difference between contract and phone service. Here we can see the table offers 3 distinct values for the 3 distinct possibilities of contract and the 2 columns for the 2 distinct possibilities of phone service. The table gives me a cross-tabulation of the 2 inputs, a chi-square test, and even a p-value to see if they're independent, in which this case, it's not. What we can also do is create new variables in our basic analytics. We can maybe look for extra costs. What if there's extra money involved over and above the monthly charges? Do these have an effect on churn? Let's find out. First of all, I'm going to create the extra costs variable, and then I'm going to use the cross-tabulation function again. In this instance, I don't want the table and I don't want the chi-squared test. So I'm going to put tilde in place because I don't want those outputs. I just want the p-value. And seeing that at a level of 5% significance, 0.6 tells me that churn and extra costs are not independent. So there's multiple ways you can look into your basic analytics. Now that we've actually looked in our details of our actual data, why are we even using machine learning? Well, machine learning helps us in multiple ways. First of all, there's so many statistical underlying properties of our data that we may not be able to see ourselves. For example, machine learning uses multiple orthogonal directions to find maybe clusters, identifiers. It's trying to create patterns, something we might not be able to do. If I scroll a little lower, there's multiple ways to use machine learning as well. We are going to be using supervised learning. In essence, remember in the table, all the way at the end, there's the churn outcome. We know if a customer is going to churn or not. We're trying to create a model. So we already know, and we're training the model with the possibility itself. So we're supervising. We're giving them the answer and telling the model, train it like this. Hence supervised. And we're going to classify all of our outputs as someone that has either churned or someone that has stayed. Hence classification. There are other algorithms such as regression and clustering, but today we'll be focusing on classification. I've also included a link to machine learning in MATLAB to help you go through how to navigate machine learning using MATLAB. So scrolling down, now that I've explained that there are underlying statistical properties in our data, how do we know which one's best? We can't give the entire data table. Why don't we make it a little smaller? Maybe only certain variables will actually help a model determine if someone's going to churn or not. And that's where feature selection comes in. So this guide, this hyperlink that I've opened, is a guide into helping you understand feature selection for machine learning techniques. If I scroll down, you can see multiple functions that's available to you. Most of it is for classification, regression, and the data type that it supports. In our demonstration, we're going to be looking at the chi-square test that helps with the classification problem for categorical variables. See, there are other multiple options available to you, and you're more than welcome to look through these. So coming back to our script, what we are trying to do is we're trying to rank the features in such a significant way that we can extract the most important predictors out of the table and tell a model, use these predictors to actually give us a predictive churn model. So going down, here you can see me using the chi-square test to bring out each of the predictors and how heavily they sway the data. So if I scroll down and I plot this data, you can see that contract, tenure, online security, tech support, just to name the first four, these four predictors and the following have the most importance when it comes to helping us predict a churn model, right? At the end, it says multiple lines, phone service, and gender don't necessarily have a lot of weight in helping us understand if someone was going to churn or not when we give these features into a machine learning model. So I'm just going to remove the last three, as you can see, using the remove vars function, right? So I'm just going to run this quickly. And now what we're going to do is going to create a training and data set. We've looked at the data, we've understood it, everything's great. We've also looked at feature selection. So we're thinking, okay, we're going to create a model. We don't necessarily need all the columns in our table, we just need a few. We've used a chi-square test to see which columns are going to help us with creating a machine learning model. And what I'm going to do is separate this data into a training data set and a testing data set. The training data set is to create the model, and the testing data set is to test the model and then make a prediction. So now what I'm going to do is show you how to very simply make a machine learning model. I'll go up to apps at the top toolbox here. Over here, there's the classification learner app available to me. I'm going to open this and start a new session with the plus sign. Here we can see a drop down of all the variables in my workspace, and I'm just going to minimize this quickly. And because I've run this section using CV partitioning, I've created a training dataset and a testing dataset. I'm going to use the training dataset over here in my dropdown. If I scroll all the way down to training dataset, I can extract this, and with my response variable, I know that churn is in my table already. Drop down, go all the way to churn, and this is what I want to classify my data as. In the holdout validation, I'm going to use 20%, so it helps me validate my model. Over here, you can see a hyperlink to explain how to prepare your data for machine learning, and there's a hyperlink to help you understand validation that you're more than welcome to look into. So let's go ahead and start our session. Just going to expand this. So here we have multiple options available to us. I've used parallel pools so that this goes a little faster. And in this dropdown, it helps you understand all the different algorithms that's available to you that you can use to create multiple models, right? Machine learning models. I'm going to use a quadratic SVM over here, and I'm going to train this model. As it trains, I'm just going to show you over here, you can still select and deselect the features that you want, or you can even use another feature transformation method called PCA. There's multiple options available to you to kind of hone your model. At the side, there's predictors. For example, I'm just going to look at the relationship between tenure and monthly charges. After it's been trained, there's a lot of X's and zeros. I'm not really sure what the accuracy of 81.1% is. So what I'm going to do is open a confusion matrix. Here it says there's a predicted class and there's a true class plotted against each other. It's telling me 751 of my data points were correctly classified as no, and 163 were correctly classified as yes. But that's not helping me. Let me try percentage-wise. It's saying that my model could predict 90% of the remaining customers correctly and 54% of the churned customers correctly. Remember, if you drop down, you can always see other forms of machine learning models. For example, optimizable SVM allows us to drop down and choose optimizer options. For example, if you're really interested in knowing how to go in the deep details of your machine learning algorithm, for example, the hyperparameter optimization, you're more than welcome to look into this as well. So I'm just going to close this and show you that we can export the model itself at the top here and predict our function, or we can generate the function itself. So I'm just going to click this, and it gives you detailed instructions of how the app has created your model. Over here, it says it used the fit CSVM function, and there's this input, the kernel function is polynomial, and many other inputs. So going over to my script, I'll show you that I've also created a model here using fit-csvm, but I've used the kernel function linear. And when I tested the model using test data over here, it's telling me that my model could classify 38.5% of the remaining consumers correctly and 79.9% of the churned customers correctly. I might actually like this model better because remember, I want to know if people are churning. So if this model can calculate people that are churning better than those that are staying, I'm okay with that. So now let's go over to making an actual prediction. Keeping this in mind, I've just done a small test to see how many of my data was actually correctly classified. It's saying 49% of it was correctly classified using the model that I made. So what I'm going to do is I'm going to find all the IDs of the customers that have churned. Here at the top, remember, it's not have churned, I'm predicting that these customers will churn. The top is 3668 QPYBK. So now I'm going to look at the actual table itself. I'll pull the data and bring it back into the table and then look into the first 4 predictors. Remember that contract, tenure, online security, and tech support were the first 4 predictors that seem to have the most sway in telling if someone would churn or not. Once again, I'm just going to bring out that table and then let's look at how to apply this in a little bit more detail. So let's go over back into our presentation. See, as you can see, we've pulled out that first customer that might churn from our prediction, 3668QPYBK. This person has a month-to-month contract, a tenure of 2 months. They do have online security, but no tech support. So if I go back up to my presentation, now we need to have targeted marketing techniques because we've identified the customer that might churn. Now we need to contact them. We need to provide a catered solution. Here, what we could do is we could reach out to the customer and offer them tech support options, and we could offer them a longer term contract rather than this volatile month to month. So we're proactively asking them to keep staying in our company. In essence, we need to express the value proposition of these offers. This is what churn modeling and predicting churn modeling is all about. It's to keep the customers. Over time, we can fit an algorithm for customers that follow a similar trend. Now I'll be asking Import to look through one of the models, specifically optimal pricing for vacancy and revenue that we as Optimum have deployed.
Great, thanks Malavika. So what we're looking at here is a case study. The case study is actually in the housing space. In the housing space, churn is actually vacancy. And so what I'll go through here is the key challenge, the key business problem we were looking to address, what we did, and also the results of what we did as well. So basically the client that we're working with, where they found themselves was actually in a highly competitive and saturated rental market. And what they needed to do was drive profitability through a rental pricing strategy and actually do so while minimizing vacancies. And so what they needed to do this was an agile evidence-based pricing model. And that's exactly what Optimum Solutions did. We built a pricing model in order to predict vacancies when we change rental prices. So this pricing model was able to then look at minimizing vacancy while we maximize profit. And to go about doing this, we made use of the client data. But not only that, we actually made use of external data. We looked at macro and microeconomic data. And some of what we considered was CPI. CPI is the Consumer Price Index. And what this tells us is actually the buying power that the consumer has. We also then looked at unemployment. Unemployment gives us an idea of who's actually available within the rental market. And then we then looked at GDP as well, which then gives us an idea of how the economy is performing. And with this type of data, we were able to then build up pricing models. And the models we were able to build, they were actually accurate when they were built on a unit level. And what I mean by that, when they were built specifically for 1-bedroom units, 2-bedroom units, and yeah, each type of unit. And so the output of the model, if you can look in the far right, you can see the plot of vacancy over time. So in black, what we have is the actual vacancy, and in blue is what the model was predicting. And what you see is that the blue line closely follows the actual. And with that, we were then able to forecast, highlighted in red, where we expect to perform and what the confident bounds were. And so in addition to this view that we provided, we actually provided what we called the sensitivity plots. So if you can move on to the next slide. So these are the sensitivity plots to give us a better view of how sensitive particular units are to rental increases. So what we have is on the x-axis, we have the rental changes. On the y-axis, we then see the impact on revenue and also the impact on vacancies. And on the left-hand side, we're looking at large units, and then on the right-hand side, we're looking at small units. And these two subsets follow different dynamics. So with large unit, the moment you change your rental prices, you find that your vacancy shifts and changes. You find that vacancy increases as the rent increases as well. And so does your revenue, but it does so at risk of losing tenants. And then with smaller units, what you find is that as you increase rent, your vacancy actually drop over time and you're able to then drive revenue. And so what we see here is that larger units are highly sensitive to rental price changes, while smaller units are not. And one of the key things that we looked at was to investigate this a little bit further to understand why smaller units behaved like that. And so a huge component, and it came out from the feature engineering, it showed that smaller units are actually sensitive more to the economy than they are to the rental increases. So when the economy is actually good, what you find is that people do prefer to live alone, and so they do rent smaller units, right? But then in a bad economy, what you find is that people actually start downsizing, they move into smaller units. So whether you're in a good economy or a bad economy, people are occupying smaller units within that particular market that we were looking at. And so stepping back and then thinking about the pricing strategy for larger units oriented in such a manner that then the client has to then look at pricing in a way that protects vacancies. So larger units were more oriented in terms of driving vacancies, while smaller units were more oriented towards driving revenue. And so then the client was then able to have unique pricing strategies for each unit type to then meet the business objective of minimizing vacancies while driving revenue over time.
Thank you, Mpo. Right, so just a few next steps. If you have any questions regarding both churn modeling or applying this in your business strategies, please feel free to contact either myself or Mpo at optimum.co.za. Also, join us for a few of our other webinars. We have 3 remaining in November and 1 more in December. There will be a survey that's going to be posted into the chat. Please feel free to complete the survey and you'll have access to both the live script and the data to run the script. And now let's go into a few questions. Yes, Michael. Please feel free to unmute yourself if you have a question as well.
Yes, thank you. Thank you for the nice presentation. I just have a simple question. those code that you use to make all those plots, can you make it available for us? And that's the first question. The second, are you going to receive the invitation for the remaining webinar?
Michelle will be
Yes.
able to answer those questions. So Michelle has said that the recording will be provided and the information on how to access it will be given to you in the next week. And Michelle will the invitations for the remaining webinars as well.
Okay, thank you.
You're welcome. So I see Leon has asked a question. How can GPS hardware be used to speed up analysis? I can see that Jeremy and Michelle are both typing, so I'm just going to wait for them before I carry on. GPU hardware. All right. Paul and Jeremy, I'd just like to ask you, have you used GPU hardware in any of your analyses to speed it up?
Hi there, this is Jeremy speaking. Yes, so MATLAB actually enables you to use GPU hardware to speed up applications as long as they are CUDA GPUs. So it's actually as simple as enabling that functionality when you're using parallel computing. So yeah, I mean, it's something we could possibly share in a future webinar. Actually, I think there's a lot of interest in that. But I guess the short answer to your question is yes. If the processing enables, or if the processing you're doing is parallel in nature, then yes, you can use GPU hardware.
Thank you. Michael, I see that your hand is up. Do you still have another question? All right. So please feel free to unmute yourself if you have any questions. You're more than welcome to ask, or you can keep your questions in the chat and we can read them out and answer those as well. So I'd just like everyone to look into the chat again. There is a feedback survey that Talita has posted onto the chat. Thank you so much for joining today's webinar. If you have any questions, please feel free to reach out to Optimum Solutions if you have any questions, any queries, and I hope you enjoy your week. Thank you so much for joining.
Oh yeah, thanks everybody.